Assalamu alaikum wa rahmatullahi wa barakatuh, dear grade 8 students. In this video, as I promised you, I'm going to tell you why is the area of a square equal to diagonal squared over 2. All of us know that the area of a square is equal to side squared. Now I'm going to prove it in another way, and I'm going to use that property after proving it, that the area of the square is equal to the diagonal squared divided by 2. And here we go with this figure. I have a square of side 4 centimeter. Regardless of the side, I'm going to find its area. If I don't have the side, suppose that I don't have that side, and I'm going to have its area to calculate its area using its diagonals. So first of all, let me join the diagonals, B to D and A to C. And as you know, diagonals of a square are axes of symmetry for that square. So those diagonals are axes of symmetry, thus they are perpendicular to each other, they are bisecting each other at the same midpoint, and as well, I'm going to get that this triangle, let me shade it, that triangle B, for example, FC, is a right isosceles triangle because it has two equal sides, because the diagonals are equal and bisect each other, and they are perpendicular here. As we see, every time we talk about diagonals, we notice that they are making a right angle here, and according to that square, you notice that it consists of 4 congruent triangles. These triangles are all congruent, so they are right isosceles triangles because the diagonals are equal and bisect each other, so all of these segments, or these 4 segments, are equal, and thus the diagonals are the triangles are all congruent, and we have 4 congruent right isosceles triangles. Now if you notice that the area of that square must be equal to 4 times the area of any one of these triangles. So the area of that square is 4 times any one of the areas, 4 times the area of any one of these triangles. Now let's find the area of one triangle, and then we are going to multiply it by 4 to prove the rule that says that the area of a square is equal to diagonal squared over 2. According to this triangle, let me start by the rule of the area of a triangle. The area of any triangle is height times base over 2. So it is height times base over 2. That's the area of any triangle. Now, according to that right triangle, I can use BF as a height and FC as a base, because it's a right triangle, so I can use these as a height and as a base. So I have to just substitute or replace height by BF, base by FC, and we still have over 2. So we are just replacing the height by BF and the base by FC. Now again, according to BF, if you notice, according to BF, it's half of the diagonal BD. So BF is half of the diagonal BD, so I can definitely write D over 2. That's what we mean by half. And for FC also, it's half of the diagonal AC, so I can replace it by D over 2. I'm replacing by letter D because I'm supposing that I don't have numbers, I don't have measurements, and I'm going to get the rule in general. The rule says D squared over 2, and I'm going to reach that rule using the letter D because letter D goes for the diagonals. And we still have over 2. Now, according to multiplication of fractions, I multiply the numerators together. D times D gives D squared, and 2 times 2 gives 4, and all of that is over 2. That's like writing it in that way, D squared over 4 divided, so it's over 2 means divided by 2 over 1. Now, according to division of fractions, so here we are reviewing multiplication and division of fractions. It is d squared over 4, and as you know, switch the division sign into multiplication sign and flip the second fraction. And thus, we got d squared times 1, d squared over 8. That's for one triangle. So the area of that triangle is d squared over 8. Now, let me talk about the area of the square. The area of the square is 4 times the area of each triangle, as I just told you at the beginning of the video. So it's 4 times the area of the triangle is d squared over 8, and thus by simplifying 4 and 8 we will get d squared times 1, which is d squared, and still we have 1 times 2 downwards, so we get d squared over 2. And by this we prove that the area of the square using the diagonals is equal to the squaring of the diagonal divided by 2. And we use this property whenever we don't have the measurement of the sides, but just we have the measurement of the diagonal.